So we are going to learn about topic modeling. What is topic modeling? So there are many things that we will discuss in 3 hours. First, we will look at the definition. What is the definition of topic model? And what are the application of the topic model? So we will take a look on the topic extraction, relationship between the topics, the trend analysis, and the document retrieval. And for today, I think we will learn the basic concepts. And for tomorrow, we will learn some algorithms. If we have enough time, I will explain all the algorithms. But if there is no enough time, I will skip one. So maybe this algorithm is still, if I take, if it takes more time, maybe I will just skip this one. So topic modeling. What is topic modeling? We call it topic. Topic is subject, okay, subject. And we want to make a model. If you have any input from an input corpus, so corpus, we usually say this is a collection of documents, a collection of text. So from this corpus, we want to get a number of topics. Let's say I have K. So K is decided or K is determined. For example, I want to look at 3 topics, then K will be 3. So if K equals to 3 means I will split this corpus into topic 1, topic 2, and topic 3. So for example, there are many words here, and we will check whether the words belong to this topic, or the words belong to this topic, or the words belong to this topic. Because there are so many documents, sometimes we cannot cluster or we cannot group. Then we need to decide the groups, and we can verify how many K or how many groups that we want to create. Maybe the basic idea is similar to clustering. If you learn on the data mining or data science, you know about clustering. So the idea is similar with the clustering. From a group of data, we want to make 3 different clusters. And for each cluster, we will have some terms. For example, the topic 1, it is related to computer, technology, system, service, site, phone, internet, and machine. The topic 2 is related about sell, store, product, business, advertising, and etc. Topic 3 is about film, play, movie, theater, production, and so on. Then, yeah, we can generate other kind of topics. So this kind of topic modeling, we can also see a kind of relationship. So what topics are expressed by that document? For example, if the topic 1 is here, so we can see any line into the topic 2. So sometimes there are some documents that can be in topic 1 and it can be also in topic 2. So there might be some kind of probability. If the probability is higher to topic 1, then yeah, we will assign this document to the topic 1. If the probability is higher to the topic 2, then we will assign this document to the topic 3, and so on. So this kind of figure show that if this document is more in the topic 1, then the probability is high on the topic 1. What about here? So this document is somehow have no relationship to topic 1, no relationship to topic 2, have no relationship to topic 3. Or maybe we can say this is the document which is not related to any kind of topics. But still, we can get the probability. The probability means what is the possibility of this document belong to topic 1, what is the possibility of this document belong to topic 2, and what is the possibility of this document belong to topic 3. So this is an example about the topic extraction. When we do the topic modeling, we want to extract. It means we want to check what are the possible topic. For example, this is a list of 30 topics discovered for deep learning. So when you search a research paper about deep learning, so we can extract those kind of particular topics. For example, fault detection with DBN, convolution neural network, network learning, and so on. So this is the topic, and we can see what are the terms in this topic. For example, here the terms are layer, input, output, unit, height, and function. So let's say this is another topic, deep learning architecture. So the term or the words that appear in this topic is deep architecture, neural, standard, explore, and so on. So this is one example of the topic extraction. So it is another example. It is a topic extraction, and there are 50 topics discovered for ultrasound or ultrasonography. So there are many documents related to ultrasound or ultrasonography, and we are going to group them. So most of those words like plaque, IVUS, coronary, intravascular, and so on, they are in this topic. Those words are in this topic, and so on. So we can extract the topic based on the words. This is another example about thread. So this is a collection of documents about insider thread. And again, we can find a list of words that are related to this topic. You can see a list of words related to this topic, and so on. From this topic modeling, we can also see the relationship. What is the relationship? The relationship means if a document or if a topic related to image processing, we want to know whether there is a relationship with another terms in another topic. So this is, for example, topic 1, this is topic 2, this is topic 3. So we want to know if the topic 1 shows image retrieval, and we want to know whether the topic 2 also contain the image retrieval or not. Or we want to know if the topic 2 contains a word or a terminology that has relation with another word in different topic. So we can make this kind of relationship. This is a relationship between topics in the big topics about deep learning. Or let's say we want to see the relationship between the topics and the big picture or big topic is Internet of Things. In the terms of Internet of Things, We can see it is a topic about RFID, or this is a topic related to the smart place and energy efficiency. This is also another topic related to WSN and protocol and so on. If it is related to RFID, it has some keywords like optimization and simulation, object detection or recognition or tracking, and so on. And we can also look at the frequency. If it is high frequent, it is most probably it is a hot topic. If it is less frequent, maybe it is a cold topic, not that popular. So hot topic means it is popular. So the frequency is high. If it is cold topic, then it is less popular. So the frequency is low. We can see based on the time. Let's say we want to look at the trend analysis. So the trend means we will have time. We have time. If we get the data based on the time, we want to know how many articles related to this particular topic, or let's say this is T2, topic 2, and then how many articles in the particular time. So this is from 2000 until 2015. So if we can measure those documents, then we can plot with this line plot. Okay. So this is the topic trends for technology and innovation management. So this is the topic 2. This is topic 12. This is topic 5 about the open innovation. This is topic 11, topic 13, and so on. Okay. So any documents that has been classified into this topic, we will check and we can plot it based on the frequency. The other kind of topic modeling, we can look at this kind of document retrieval. For example, you have a lot of magazine. We have a lot of magazine, 잡지, and then all those magazine, every magazine, they have their own subtopics. For example, this magazine is a magazine related to food. So food can be anything, maybe fast food, or maybe dessert, or maybe burger, pasta, cookies, and etc. So there are many kind of categories. And how can we retrieve the particular topic? So this idea, we can use the document retrieval. It has been there was a research work from this guy in 2015, and they can create about 250 topics from the magazine. And we can see from those 150 topics, what is the frequency on particular topics. The other kind of topic modeling, yeah, this is another kind of research. It is a topic modeling analysis of living lab research. So they want to look at the living lab research in the context of urban city. So they collect all the documents related to the urban cities, and then they make the topic into 1, 2, 3, 4, 5, 6, 7. And then from those 7 topics, they want to look at what are the important keywords based on the topic. For example, the topic about design. This is another kind of topic which is related to living lab and so on. So there are many kind of application. We can look at the topic modeling. And this is another kind of application. You can see how the audio, the meeting if you record the meeting with the audio, then you can summarize what is the meeting notes or what is the content of the meeting. So automatic meeting summarization and topic detection system. So if you record all the audio, the system can recognize who are the participants. So they can recognize the name. Okay, there are two participants, Tram and Kenny, for example. And then they can make the category. So what are the discussion about? Okay, the category will be about this one. Maybe this is from the China, so they use the Chinese language. And then they can do the summarization. From the audio, you can make the summarization, and we can use this summarization as maybe one topic. The key idea of the topic modeling actually is from the document, and then we need to select the particular word which might be interest for being a topic. So this kind of word, we need to check the distribution. The distribution will be a kind of histogram. And if we know the distribution of each of these words, then we may give some kind of assignment to a particular topic. For example, for the topic 1, most probably it is related to the word basic. The topic 2, maybe it is related to the word function and didactic. The topic 3 is a topic related to the circuit breaker, current flow, and so on. And after we know those topics, if we already make this categorization, then we can create the topic distribution. So the topic distribution means how many documents related to the topic 1, how many documents related to topic 2, how many documents related to topic 3, how many documents related to topic 4, and then we create some kind of word distribution again. Let's say we have a new document. Then we can check this new document. If it belongs to the topic 1, what is the probability? If this new document belongs to the topic 2, what is the probability? If this document belongs to topic 3, what is the probability, and so on. The highest probability of this document will be assigned to that topic. Usually we use this kind of matrix, or if you learn from the data science, we have the heat map. Okay. So this kind of heat map will give you some idea how to make the topic. Okay. So automatically extract topics from the text document. So for example, using the term document matrix. So in the document 4, the word blood. Okay. So the frequency on the document 4 contains the word blood. So this is because the color is dark, we can say this is a high occurrence. If the color is white, then it is low occurrence. Then the color is black, the frequency is high. On the word arms in document 6. If you look at this word, the environmental, so this document is high occurrence. Then we can do a kind of clustering. In the clustering, we can check the distance. So we can calculate the distance. If the distance is similar, or if the similarity is high, then we can make those into one group. So let me just give you one simple example. If we want to assign the topic based on the keyword, so we can apply simple word frequency count methods. So this emphasizes the use of the raw term frequency. Raw term frequency means we just calculate how many. Let's say if there are two, then we just point out there are two words. Or sometimes we call it, this is the term document matrices. The term means the word. Sometimes we use term, it is to indicate the important word. If we use word, usually it is also including the stop words. For example, is. Is a word. At is also a word. But we call term means something more specific related to topic. So for example, we have the maybe from the previous one, current, flow, or we have the term about data. Okay. So something that we can extract and something that is important or something that is obvious to a particular topic. If we are using the word, usually it is more general. If we use term, it is more specific. So people or some literatures, they directly mention the term document matrices. The simple approach is the method relies on the predefined keywords, such as associating specific words with certain topics. For example, I have 5 documents. So those 5 documents, the first document, we have the word I love basketball. The second document, basketball is a great sport. Document 3, I enjoy watching movies. Document 4, movies are entertaining. And document 5, I love playing sports. Now we can calculate the term document matrix. So let me just make it simple. So I put everything, okay, including the I. We can calculate the word. Okay, we can calculate the term for every document. Okay, document 1, document 2, document 3, document 4, document 5. We call this is document term document because the row is the term and the column is the document. So people usually say word document matrix, or sometimes we can say this is the term document matrix. Okay. So the term document matrix means for the row we are indicating the words and the column we are indicating the document. You can see for the word I, it appears on the document 1, document 3, and document 5. For the word love, it appears on the document 1 and document 5. For the word basketball, it appears on the document 1 and document 2, and so on. Okay. So we can calculate the frequency. After we have this matrix, now we can use the predefined topic. What does it mean by predefined topic? 미리 정했어요. Okay, so we already defined if it is topic one, then there should be word related to basketball, sport, play. For the topic two, so the predefined topic is related to movie, watching, and entertaining. So we already defined. Then if we already defined this one, we can make the term document matrix into color. For example, this one, the red color indicates the topic one. So the basketball, sport, and play. The topic two, it is related to movie, which is in the blue color, watching, and entertaining. Okay. Then the other kind of words is just a general word. So there is no particular topic because we cannot indicate love, we cannot indicate great, we cannot indicate enjoy, and also I. Okay, so it is not, we cannot decide whether it is something about the sport or something about movie. Okay. So we can have this particular predefined topic and then we can calculate. Count the number of frequency of each topic. Now, in the document one, how many keywords related to basketball, sport, and play? Okay, we have one red color. Okay, then the topic one has the document one can be in the topic one because there is one frequency of one of the keyword, that is basketball. What about in document two? In the document two, we can have basketball and sport. So there are two words. What about document three? They are zero. Okay, zero, zero, and zero. What about in document four? We have zero, zero, zero. What about in document five? We have zero, one, one. Okay, there are two are related to the topic one. Now let's see in the topic two. So for the topic two, again, we will check the blue color. For the document one, 0, 0, 0, then is 0. For the document two, it is 0, 0, 0, then 0. For the document three, we have 1, 0, 1. Then there are 2. For the document 4, we have 1, 1, 0. So there are 2. And for the document 5, we have 0, 0, and 0. So 0. From this frequency, yeah, we can assign the topic based on the highest frequency. For the document 1, then we can assign to the topic 1. For the document 2, we can assign to topic 1. For the document 3, we can assign to topic 2. This is topic 2 and this is topic 1. Okay. So this is using the predefined topic. Okay, let's see the code. I make the simple code. So I use the count factorizer to calculate the count. So the documents are the same with the example in the PowerPoint. We have 5 texts or 5 documents. I love basketball. Basketball is good sport and I enjoy watching movie. Movies are entertaining and I love playing sport. So we need to define the topics. it is not easy, but in many methods or in many basic methods, they use this kind of way to make the topic model. So let's say in the topic one, we want to collect any words related to basketball, sport without S, playing, and sports with S. The topic two is about movie, watching, and entertaining. So we can count how many times of those words appears, and then we will put it into the variable X for the document. So we have this document. And then we put into the data frame and then check how big is the document related to the topic one and how big is the frequency of those documents belongs to the topic two. So we will assign the topic. If the topic one is higher than the topic two, then assign topic one. Otherwise, assign topic two. Then this indicate the document 0, document 1, 2, 3, 4. This document 0 because the word in the topic 1 has one frequency, then we assign to the topic 1 and so on. So this is based on the what we learned in this PowerPoint. Okay, based on this one. This is the very simple method, and of course it has limitation. So the limitation, first, it is lack of flexibility. So documents are rigidly assigned to one topic, cannot handle ambiguous or multiple topics documents. So let's say if the word related to sports, and then let's say I want to also have another word, watch. I watch sports game. Thank you. Okay. So for example, I watch sports game. So this word make like this one, watching. So the word watch, it is in the topic two. Sports, it is in the topic one. So those two words appear at the same time. So we have the same frequency. Then, in this case, using the frequency itself, it is sometimes ambiguous. And when we use only the frequency, it is based on the frequency, not the probabilistic. So there is no topic distribution, only all or nothing assignment to the topics. So if you use like binary, 0 or 1, then this is more challenging. And it is sensitivity to the word choice. If you want to choose the topic, then you need to predefine. The predefine is very challenging because sometimes the word does not appear as you want. For example, synonyms and slight words variation can lead to misclassification. Let's say I want to mention about soccer. Okay. Maybe in some countries they say it is soccer, but some countries they said it is football. Okay. So they are actually the same, but now we have different word, and this is very sensitive to look at the topic with the keyword base. And the other kind of problem is no discovery of hidden structure. So cannot discover new or latent topics. It requires predefined topics or keywords. So if we already define K equals to 2, let's say there is a new topic. It is not about sport, it's not about movie, but it is about the economy. So it is difficult to make a new topic with only the keyword. And it is difficult to handle the large vocabulary. Yeah. You know that there are many words in English, also in Korean. Yeah. So with this simple keyword topic assignment, it is not possible for a big document. So that's why we will learn more complex algorithm. So the topic modeling, we can look based on this classification hierarchy. So first, we will take a look about the non-probabilistic. The non-probabilistic, there are two algorithms that we will learn. The latent semantic analysis, LSA, and the non-negative matrix factorization, NMF. For the probabilistics, there are two, which is the probabilistic LSA or PLSA, and the other algorithm is LDA, latent direct allocation. So last time I show you the Python code using the LDA. If the time allows, I will explain the LDA. It requires some steps to understand this one, but okay, let's see about the time. If it is about the probabilistic, so the PLSA, the LDA, the PLSA will use what you already learned before, tag of word, sequence of word. So we need to make the word representation, or we need to create text representation. If it is using the LDA, if it is a supervised, then you can use also the back of word and the sequence of word. If it is unsupervised, again, we can use the back of word and sequence of word, and we can create something like the representation such as TF, IDF. If it is the LSA, we still can apply the back of word and the sequence of word. But for the N and MF, yeah, we need to apply some linear algebra method. So, okay, we will take a look on the details on this algorithm tomorrow. Okay, so I will stop here.